Hello, everyone. I'm asking you to come on in and take your seats. And now I'm going to turn this over to Rosa.
Actually, I'm not sharing the session, nor do I have any special announcement. It's just that this meeting is so full of friends, really meaningful people. I think it's my favorite meeting in the world. Actually, I have to say something that first time I entered a Global Hands-on Universe meeting, it changed my life forever. I was still doing research. My field of expertise is black holes, and I was heavily dived into my research. And when I went to this meeting in Provence, I met some of the people here in the audience and some of the people that are not here. And I found what you are finding here. I don't know, I hope you are all finding it here. It's unique. And it changed my life. I decided to devote my life to this forever. And I knew it was a lifelong mission. And so far, I don't regret. I've been meeting more and more special people. I think that each and every one in this room is a special person. So I would like to make sure that this is recorded for the future. But among these special people, I met Babak. Is that correct? Babak. You know that in Portuguese, we have this word babaca, which is like a silly person. So, and he caused a big impression on me because of his big heart. I'm not going to share the session. We have very skillful Bonnie, who is another special person that I met in this journey. And but I did wanted to say that I'm really so proud to have all of you and all the special people. Babak is a very, very special person, changing the world where he goes, enlightening people. And if there are any politicians listening to me, invite him to your parliament. He will give you a completely different view of what's important in the world. So Bonnie, the floor is yours. Sorry about that, but I had to do it.
Okay, so this afternoon you get to listen to me murder everyone's name. So I want to present Babak Tanfreshi. Oh. Okay, I would like you to come up here and tell us about your exciting experiences.
Thank you, Rosa and Bonnie, and thank you everyone who is involved with coordinating this wonderful event. It's great to see everyone again and meeting new friends here. My talk today is not about the Word at Night program, but some of these images are included in the presentations that I'm going to show you. It's more about our recent trip in Chile. We do it every few years for the European Southern Observatory, or ESO, to create new imagery of their sites under the night sky. So these images are made for PR, for communicating with people, and also it's available for educators worldwide to use them free of cost. They're also available in amazing resolution, so that means you can do a lot of things with them, including printing very large, zooming in, and video animations, and using it in planetariums, because a good number of these images are made in full dome. And ESO itself is going to use them in an upcoming planetarium in Munich, but it's available at the moment online at ESO website for all educators for any kind of non-commercial use. Even commercial companies are using some of our images, which might be not according to the agreement, but that's okay for ESO so far. So let's start with what we have done. The purpose of the images was, of course, the astronomical sites, including Paranal, La Silla, Alma, but we also take pictures anytime we go to Chile, of the atmosphere and environment of the area. That means the Atacama Desert, the Altiplano Andes at night, and the cultural aspects of the country under the night sky. So these images are not deep photos of the night sky. They're not telescopic. They're made with wide-angle lenses to connect earth and sky in a single frame. Some of them are large panoramas, like this picture on the right side from Paranal. It can be printed up to 10 meters, for example, due to the resolution it has. And these pictures are showing the southern sky for the educators, but a good number of northern constellations are in the pictures too. They show the constellations, they show the Milky Way, the neighboring galaxies. These images are often detailed enough to see deep sky objects such as the nebula and star clusters. They have captured some of the atmospheric phenomena, celestial events such as celestial conjunctions or eclipses, depending on what time we have visited the sites. Air glow, for example, is evident in many of the pictures, which is part of the atmospheric phenomena we're talking about. And they're illustrating where the astronomers are doing their observations. So this is important for astronomers who are doing classes, doing education, to show people where we are working and why the dark sky is important to be preserved at such locations. And they are also standard for educators and photographers regarding the color of the night sky, because these days you see pictures such as this made by many photographers who are not really familiar with natural looking sky, and the Milky Way appears in all colors possible. Some release images of the Milky Way in red, the other one in purple, in blue, and it's completely lost. What is the natural looking wide-angle picture of the night sky? The digital ability of processing has changed this habit to keep it natural looking, and saturation is becoming more and more, unfortunately. So a part of our mission was to release images that are calibrated regarding color. This is not for scientific use, but still this is a standard according to our knowledge of what Milky Way should look like in the images. Our team was four. Here is me and Yuri Beletsky, former ESO astronomer. Now he's working in another observatory in Chile, but is still an ESO photo ambassador, including also my colleague Christoph Malin, who is also a TWAN member, the Warden Knight member in Austria, and Herbert Zodet from ESO itself, who was our leading person. And behind that, we had a good number of people working at ESO itself, at the Public and Education Department, including Lars, who was the main organizer of the trip. Let's start images. From now on, I will show you what are the options we have in these imagery. Most of them, or nearly all of them in these presentations, are my images, but my two other colleagues who were photographing and doing time-lapse also contributed to the collection we have currently on ESO website. So in this picture, at the moment, you might not see anything specific at Alma site, but if we just zoom in, then you realize there was a very thin crescent moon above the antennas, only less than 20 hours old, near the conjunction. So that's why it's so close to the horizon, but from that high altitude, over 5,000 meters, the horizon is so clear and transparent, you can capture objects like 1 degree above the horizon. But of course, doing the job up there was not so easy, not only because of the altitude and the temperature, but there are a lot of security things you need to follow up on Alma when you want to stay overnight, several nights there. We need to have oxygen capsules working like these on the back of Yuri, you can see. Of course, you can check your oxygen level time to time, every 20 minutes, to see if you need it or not. But I had a very interesting experience up there this time. And it was checking the visibility of my eyesight with and without the oxygen capsule. And it was very stunning because without the oxygen capsule, of course, at the safe level, the sky didn't look really impressive. It was something like somewhere in Atacama, like limiting magnitude of eyesight around 6. But then with the oxygen capsule, everything was so prominent. I mean, it was one of the best the sky ever had. So I just turned it on and off every hour or so to see how the sky is changing to my eye. Here's another single exposure photo. Many of these images are single exposure or panoramas. That means stitched digital panoramas. Some of them are star trails, but we don't do composite images. That means we don't take one image of the foreground and one image of the background and merge them together in Photoshop. These are all real images, single exposures. And doing a single exposure image of Carina Nebula with an antenna, it's not an easy thing to do because you need to control the exposure. If you want to track the object, then the foreground will be blurred. If you want to keep the foreground fixed and sharp, then the object on the background will be trailed. So that means you need to use very high ISO, and the best friend here is, of course, the transparency of the sky that helps us. And of course, we were mostly using the modified cameras, DSLR cameras, which are modified for astronomical purpose to capture more of the H-alpha emission. This is the Milky Way over Alma in the morning twilight. The view from the southern sky, the view to the galaxy is impressive because you see the galactic bulge coming overhead, especially in this season. So that allows you to see this spiral galaxy edge on. The environment around Alma, near the Alma camp in a valley, we had a big earthquake at that time in Chile. We were right in there, and we found ourselves a bit dizzy, like headache for 10 seconds. Then we realized it was earthquake. Alma site from outside, now we are on the plane and looking like 10 kilometers away. The big object in the sky, the red one, is Mars near the opposition. Near Alma, we have this wonderful natural attraction called the Valley of the Moon. There's also an observing site, a telescope farm for astrotourism run by a former French astronomer who is now living here. It's a hotel for astronomers. Now we are going across Atacama to more southern area where Paranal is located. You can see Paranal on the left, and next to it is Vista Telescope, the second peak during sunset. But the view is captured from Armazones, the location for the next telescope, for the EELT, the 40-meter telescope. Road to Paranal. Now in the morning twilight, one of those celestial events is captured. Up there is Venus and Moon rising in the morning twilight while the galactic bulge is in overhead. The telescopes are finishing their work, the enclosures are closing. Another look at one of the auxiliary telescopes. In the background, some 20 kilometers away, direct distance, is Armazones. Now this mountain looks a bit different because they have started to flat the top. Explosion started this May and continues. A night in Paranal. Let's see a video. So many of these shots are also made in time lapse. That's a kind of self-portrait, in fact. See a passing satellite in the sky. Now we're zooming in towards Sagittarius. Lagoon Nebula is on the lower left, where is the direction, almost the direction of the galactic center. Our next jump is even a closer look in a telephoto view with the Large Magellanic Cloud over one of the VLTs. This is a single exposure image. Now inside. Now the colleague photographer of the team, Christoph Malin. He's expert in time-lapse imaging. Christoph at Borg, beginning of the night. Another look at Paranal. Now this one with the sky glow filter, it increased the contrast of the night sky so we can see the nebulosity much better over Cerro Paranal. A closer look to Southern Cross and Paranal. Yeah, this one is in Armazones. So I think this is the first 360-degree image of Armazones in this resolution. So you can see all the sources of light pollution in future for ELT, including that mine over there, which is almost 80 kilometers away, and as well as the nearest town. But the glow on the left side is the zodiacal light. The glow on the right side, the red, is air glow. Star trail image from Armazones in half an hour. So, may I have 2 more minutes?
Yeah, go ahead.
Yeah.
I'm fascinated.
Now we're looking to a nearby Oasis Observatory. This is owned by Bochum University in Germany, and it's a wonderful observatory next to Armazones. Now, not alone anymore. At night. It's also, as far as I know, the only completely green observatory. There is no connection for electricity, anything to this observatory. So all the energy is created here. Now we are at La Silla. It's almost outside of Atacama Desert in the outskirts. Christoph is preparing for time-lapse from day to night, transition. Now we are seeing a wonderful sunset, but there are some clouds. This is rare, of course, in any of these ESO observatories, but it happens time to time. And it gave us a good occasion to capture these colors. The inversion layer in the desert. Now see it in motion. Jupiter and Moon is setting over the horizon. Down there, the Max Planck telescope is more active than the others in terms of changing direction. See the disturbance of the star trails at the horizon. It's awesome. You see all the distortion for the brighter stars. Here is a close-up. Even a closer look. So we usually see this from moon or sun at the horizon, but for stars it's difficult to capture unless you're somewhere with some negative angle of the horizon visible. I also capture in this time lapse a meteor, and have a closer look at the meteor. You see it's how the dynamic of the meteoroid coming towards the atmosphere and changing its path across the atmosphere has caused this a strange pattern. Another one with the NTT telescope, a closer look. This is a 3-meter class telescope, 3.5 meter, and the enclosure was a first of its own when it was introduced to astronomy. Looking inside, the Milky Way over the telescope, single exposure again. Another single exposure which even surprised me because the cluster the 47 Tucana is resolved in this telephoto image. La Serena is growing, of course, so it's a concern for La Silla, but then this image is a bit brighter than usual because of the cloud that has scattered the light pollution. I found La Silla, that might be a bit surprising, a bit darker than Paranal in our images. So I can't really explain that, but this is a very little difference. But this was my personal experience in the images. The sky background was a bit darker than Paranal. Zodiacal light. In the morning twilight, you can see Venus in the middle. The LMC, And these are the few last images which showcase the eclipses, the total lunar eclipse that we experienced there. The red moon, or as some media started to call it, the blood moon. So yeah, this is my last image, and this eclipse moon is captured next to planet Saturn and Mars. Saturn is in middle, Scorpion on the left side during the total eclipse. So thank you. All these images, nearly over 90% of them, are available on ESO websites, and you can use them for education. And some of them are in giant resolution to print large. Thank you, everyone.
Is this a switch? Thank you very much. Ah, half-lit. Okay. Now we're awake again, I guess. Thank you very much. I actually have used some of your images as screensaver on my computer because I love them. And people are always asking where did I get those images? Okay. Now we have Lena Canes. And Lena is going to tell us about tactile astronomy. Are we having, yes, okay, let's have questions. Carl has a question.
I suffer for all you. May you suffer because of me. Hey, boy, those are beautiful. Wow.
Thank you.
I think this is some of the great art of the century, to my mind. Great art and science. Just a round of applause for. Yay.
The part of the copyright is, of course, the Atacama Desert.
Yeah.
I mean, the greatest sky up there.
Yeah. Now, are the stars really that blue? You haven't adjusted them? I noticed a few images.
Like this picture. Of course, this one is blue because this is a Spica in Virgo. It's a blue giant.
Oh, wait, it's not the right.
You mean this one, or?
There
Like
are
those
two
stars.
images with hugely blue stars. And I thought that was very educational to see them that color.
Yeah, these ones. Yeah, these are all giant stars in the tail of a scorpion. Yeah, these blue are really.
And
blue.
that's real true color.
Yes.
Wow. I haven't seen it so.
Yeah, exactly. One point you need to remember that we have used a diffuser filter in front of the lens to scatter the light of brighter stars. So that diffuser also shows the color a bit better than normal photographs.
Very good. That's excellent. Okay. Thank you.
Sure.
Okay, I'm going to have to ask you, excuse me,
Sure.
so that we can move on, to save your questions and remember what they are for the coffee break, because we have several more speakers this afternoon.
Sure.
Okay.
Yeah, I'm here all the time.
Thank you very much.
Sure.
It was wonderful. Okay, now we have Alina Canes, who is going to talk about tactile astronomy.
Tactile astronomy, yes.
Okay.
But, first, I would like to make some announcements.
Okay, but first she, as her other role as chair of this, as chair of this conference, she needs to make other announcements.
Yes.
Okay.
Okay, so please just bear with me. It's just a small announcement for the dinner. So everyone knows that it's to be outside at 5:45. Is that okay? Everyone has that in okay. So, and the dinner, so if anyone who's here hasn't yet not paid for the dinner, well, you know who you are. So please join us in the reception and registration desk so that you can proceed to the payment. Okay? Thanks. I'm sorry. Okay, so now for something completely different. My presentation is basically an overall on the tomorrow's workshop. Sorry, I just can't quite get this. So it will be on tactile astronomy. Sorry. Okay, I think we all agree that astronomy is a very visual science. I mean, I think we're all on the same pace here. So how can we engage and reach children who are blind or visually impaired? So there's several projects operating around the world which are basically a joint collaborative projects. You see all the logos over there. So the first project that I started collaborating was the Sky in Your Hands, a planetarium show. This was sponsored by Ciencia Viva. I think Katia is here, yeah, from Ciencia Viva. And they allow us, back when I worked in a planetarium, they allow us to have the tactile spheres for the original project. And so, based on that, we could do a tactile planetarium show. Amelia will be here. She's the international coordinator for the project, and she will talk much more about this. So we, in the spirit of collaboration, we went to Lisbon. I think Isabel is here somewhere. Yes. So we challenged the planetarium from Lisbon to adapt the show and show it in their planetarium. We also had a tactile exhibition at the same time. So you can see here, many of the images were adapted from other projects that are already existing. So I think it was a lot of fun. We will talk about this tomorrow more thoroughly. We also have another part of the exhibition which wasn't the tactile images only. We had an actual 3D moon. So there you can see it. It's quite an amazing resource. Actually, it's an exhibition out there, so if you're free to go there and try it. It's a very good 3D model of the moon. So we thought, okay, so let's not stop by a planetarium show or an exhibition. We should go for observing. So when you think observing with a telescope, you think peeking through a hole, and so basically it's a vision-based activity. So how can we reach and include people that cannot see, that are blind? So we organized observation sessions by telescope, and for instance, this one specifically for the moon. So we had the telescope pointing at the moon, and we had the tactile counterpart. So we could simulate the whole observing, and we could explore the telescope by touch, and then we could have the tactile equivalent of what we were actually observing. This is a touch of the universe. Amelia, like I said, she will be here presenting this on Friday, so I won't mention it more. All these materials are included in this kit. This is a project that we have with our friend Samir Durda, you have the name there, and he's from IUCAA. He's from India, and he's a brilliant guy. He's very creative. So he planned a do-it-yourself planetarium based on cardboard, and so this is really low cost, and you can use this planetarium in class to engage children that are blind. Once again, it's a tactile planetarium, and the children that are sighted. So it's basically interactive activity based on a half sphere, more or less, like you can see, that you can use and actually implement in class. So we found this idea very good. So we implemented it in a school here in Portugal, thanks to teacher José Fanica. I understand that he was coming, but I'm not sure he's arrived yet. So he was kind enough to let us try this activity in his class. So it was brilliant, really. I truly, if there are any teachers here that are interested, I truly recommend this. This is very, very good. We do also other activities also on distances, because sometimes it's kind of hard to understand how these children perceive how the planets, what are the actual distances or the models that they build. So what we do, it's all tactile. You can see that it's both the nameplates. It's kind of a role play. So each student is a solar system object. So they begin the activity of imagining, okay, so relatively to the sun, where am I? And they just place they just distribute as they think the solar system is. And then we actually discuss what are the misconceptions that they have. This is all done through touch, so they can understand at the end of the activity what is the real distance. Again, this is all with low-cost materials, so everything is available at a really low cost. Then we moved to real-time telescope observation. So, okay, we had the tactile 3D moon model, which was awesome, but we wanted to be able to go at regular observation sessions and not only observe the moon, but to actually reproduce what we were seeing at a larger scale. Okay, so if we were observing Saturn, we wanted to actually reproduce this activity or this feeling to the blind audiences. So what we do, we set the challenge to Movimento da Beira, which held the fourth telescope gathering, which is one of the largest gathering of telescopes in Portugal. So what we did was we brought about 3 telescopes. That one over there is actually the Unaue telescope. Pedro, I don't know if you recognize it. So we brought it and we attached a camera and we recorded the images, and with a thermal printer we produce a tactile equivalent on a sheet of paper. So as they were collecting in real time, the people that cannot see, the visual impaired, could actually touch the tactile equivalent of what was being seen. So this was, it went very well. So we tried to do this in a larger scale and bring it to classroom. So why not use Folks that has actually, students can remotely operate the telescope. So why not include the blind students also, because it's really hard to engage blind students in class with this sort of activities. So based on the same principle, we're trying to implement this in class. Meet Our Neighbors, which is actually the more, currently my main project, is based on 13 tactile schematic images of the solar system, built with low cost, and through interactive activities, the students, visually impaired and non-visually impaired, can actually experience the solar system, main features. Sorry. Okay, so each step of the activities I will explain very briefly. I will go thoroughly tomorrow. So visually impaired, they basically, the children, what we do is that we present the tactile images, they explore the main features, and then we tell them to choose their favorite object. Then they need to choose the textures that they perceived by touch when they explore them, and then they have to build it. See, the children there are trying to understand, for instance, we have Mars and the atmosphere. They try to find textures that are actually could represent the features that they are discovering. So then, after they build the images, they explain to their colleagues what they just built. Again, everyday materials, easily available and at a low cost. Okay, so at this point I only show you the outcome. I mean, when we implement the actual activities, but every single activity we had set scientific goals for it and how could we achieve it, and then implement it and try to evaluate if they are successful or not. Here I won't show you that part, but if you want to know more, please just ask me. Okay, so this is the tactile experts that are testing it actually. And now, like I said, the outcomes, the fun part, I mean. So this is images from Portugal and from Ruth and Alison. Okay. And from Renata. See how cute they are. They actually built the tactile images in Czech Republic. So here is from Dominican Republic and from Poland. These are all teachers that agreed to collaborate with us. More from Romania. These were amazing. They were actually tested on more older students, but the outcome was actually quite, although the target students are 6 to 12, many times there's such a lack of resources that they take the chance to implement it even at a higher age students. Again, in India was very interesting because they implemented it directly with textures, local textures, so we could understand which textures could they use and not the ones we had determined at first. Here is Dominican Republic. Okay, so basically for this project, we wanted to especially focus on sustainability and the inclusion part. Okay, sustainability, why? Because we all know there's a initial kick of funding, and many times we can't prolong the project or keep the project running once the initial money runs out. But actually, this model proves, I'm sorry, it's in Portuguese basically, over there. So basically here, what we do is that to even lower the cost and make the project sustainable, first we find the key teachers, in this case, or key elements in each community, and we ask them, okay, so this is really low cost, so you don't have to have a lot of money to do so. So now you know how it works. Can you contribute in telling us how can you, in your community, improve the materials produced? So this allows it to even lower the cost and provides a lot of sustainability. We have also all the materials available online. Of course, everything is for free, Creative Commons, everything is basically it's available for all teachers, to teachers and educators to go to the website and go there and simply take the materials. Okay, so throughout my presentation saw a lot of logos because, well, as you've seen, I didn't do this by myself. So this is mainly sharing, the result of sharing great ideas and do a lot of collaborations. So for me, at my experience, I think with this sort of mind frame to collaborate and to share, I think we only have to gain with this. So we found out amazing people, that's my experience, amazing people doing amazing things and willing to share them. And I think the world becomes really, really, literally a better place because sometimes you kind of need that input sometimes. And we do a lot of friends along the way. Many of them are already here. Sorry, Bonnie, I know I'm over time. And so, thank you.
Any questions? No? Yes.
I just wondered what fraction of the population is visually impaired, and do most visually impaired students attend school? Thanks. Whoa, it's very loud now. Projecting into the microphone. I was just wondering what fraction of the population is visually impaired and whether most visually impaired students learn at schools that are just for visually impaired or whether mixed learning is the most common.
Okay, so for the second question, it depends a lot on the countries, actually. Because, for instance, Portugal, you have mixed schools. So basically, in one class, you can have visually impaired in the class with sighted peers. So basically, you have a mixed, let's say, class. So that is one reality. The other one is that you have separate schools, completely non-linked. And when it was, I think it was in Poland, if I'm not mistaken, or Czech Republic, I can recall it. What happened was that the kindergarten students built the images, and then they they learned about the blindness and how it was to live without sight. And then they went to the school for the blind, and then they showed them and help their colleagues explore the images. So, yeah, it's different realities, different approaches. For instance, I focused much more in schools, but for instance, there were, I think it was in Northern Ireland, that the little children went to rest homes because due to age, you kind of lose your sight. So basically, they went to rest homes and they presented the tactile images to elderly. So that's kind of a different approach also. But I digress. Regarding your first question, the percentage, I can't quite remember the exact percentage because many of the countries don't actually provide that percentage, but I can't quite recall it right now. But I will answer you that.
Okay, I'm going to say we're out of time, so thank you very much.
Thank you.
Now I have the man from a lost world. I don't know. Ugh. I also have 2 artificial hips, so this step is a little bit difficult sometimes. I now have the man from the lost worlds, Jose Gonzalez, and he's going to talk about the darkness and the light.
Well, I'm collecting badges or logos like Lina, but I don't have too much like her. So this is an image that I took in my backyard, and I have to say thanks to Babak because he told me a little bit tips last year on Volos, and I learned something with him about taking some nice pictures at night. So thank you, Babak. This is a scenario that I created with more than 200 students and 3 teachers, physics and chemistry teachers in our school last year. We try to know what happened to our sky night because we are losing. Here's a picture from Andrew White in the Jurassic Coast in Dorset in England. But I asking you, to everyone, do you remember the last time that you see the Milky Way at your hometown? Well, I remember when I was young, but I forget because right now I couldn't see it anymore. So this is a scenario to implement to basically discuss the light pollution with my students. And basically we try to engage students from the basic school between 11 and 14 years old in the 7th, 8th and 9th grade. This is the educational objectives, but basically we gathering all the topics in physics, mathematics, ICT, and all the skills that we have to gather also from students like communication, operating with smartphones, with GPS, and whatever. So basically, the school doesn't need too much materials because we can only need print materials, or maybe don't need it because we are also technology, so you can pick up the results and gathering in my mobile phone and submit to my website. One important thing is the engagement from parents, because the students have some difficulties to use the GPS or how to recognize the local where they make the observations. So they need the parents to use the GPS or maybe Google Maps and try to make the localization, the geolocalization of their observations. The first that we need to make with the students is the preparation phase. So we need to engage the students and to excite the students with image from Babak, for example, or maybe videos that we can find on YouTube or on Vimeo with a high resolution called time-lapse videos. So you can find everything over there. Maybe you can take a lecture, just like I did in my school, or maybe you can pull some websites and bring them some notions about light pollution. What is it so important to study light pollution? Why it's so important and affects me, like Rita showed us yesterday. I'm going to skip this to gain some time. Sometimes they say that it's not possible to change a city, and you can see here a city that is completely changed their public illumination, and you can see that in the second image, it seems that the light is too soft. Maybe we can not see it anymore, but you can, because the light is pointing in the right way, not into our eyes or to the atmosphere. And in the long down right, you can see some simulation that you can also make with the Stellarium and simulate the light pollution when you change the atmosphere settings. Sometimes one of the excuses is security, but security. What you can see in the upper left image taken by George, where is the person in the backyard, in the door, and you cannot see it. But if you take a look in the second down image, and you shield a little bit the light, you can see the person. Another important thing is when you receive some lights from cars, is different the response of our eyes from young people and old people. So we can point to the economic situation, because we have we need to expend less money, so the production of energy also is a pollutant source. But in Portugal, in this year, I think we can reach the 14 or 50% of energy made by green energy. But also we have 50% with all pollutants. So we need to change our way to expand our energy. The problem of global warming also. What happens is it involves and it affects the fauna, affects us and affects the animals and affects flora, etc. So we have environmental effects. Also, we have social and health effects, as you can see it, and all of these are connected. So the preparation phase, we can ask the students some questions. We can ask the students to bring to us some questions. You can see some of these questions. And the idea is to implement with the students from the 7th, 8th, and 9th grade. So we have to create groups with a minimum of one student on the 7th grade, one on the 8th grade, and another one of the 9th grade. So this is teamwork. So the student of the 9th grade has some tasks. For example, coordinate the group. Oh, he wants to be the leader. Of course, he is the oldest. But he has another task, as you can see it, according to the maturity and according to the curriculum. Also, the 8th grade students have some tasks, and the 7th grade. Another topic that is important is the geolocalization, of course. And some resources. You can find a couple of them on the internet, and this is basically, they have to take the data and work with some data. I figured out that the students on the 9th grade have some difficulties to work with Excel. So we have to help them to work a little bit on the spreadsheet, but they can manage. I think I'm on time. After that, we're going to pick up all the data, ask for each group to submit the data via Google Forms to a Google Drive, and you can pick up all the data and push it to Google Fusion Table. This feature from Google can help you to do graphs according whatever you like. You can see, for example, this graph. You can see the streets that are more, they have mods. Oh, sorry, you cannot see it. Let me push it, okay. So all the data collected by the students are here. You can see, you can create graphs, for example, the waste against the number of light bulbs. You can see the streets that are more expensive streets, for example. You can gather or build a graph with the more expensive streets, and you can touch in one of them, and you can see all the data collected by the students. Also, you can ask for some easy and mathematical formulation. For example, ask for the total waste that you have in the city. You can ask, for example, the number of the light streets in a street. Also, you can find some filters. You can use it. For example, I want the streets with more than 12 street lights. Well, this is some graphs to respond all the questions gathering from the students in the implementation phase. So, finally, according with the data, we can build a map with the light pollution in the region near our school. So you can see in the center, it's almost the school position, the school localization in the center of the city. You can see the light pollution is too high. Here, it's according with the quantity of stars that they can see at night in their region. So you can see you cannot see too much in the center. You can see a little bit more around the city. So this can be done by students and working together, and also with teachers. They can come and discussion and make some explanation with the observations, and also they can, the final phase that is communication, dissemination of their research. So they can build posters, make some exposition, photography. There was one of my students make a beautiful poem, but it's in Portuguese, I cannot read to you. Well, explain to the parents how the things are working, why it is so important, the light pollution, and the parents are engaged because they want to know more about this topic. And you can see using Salsa J, spectrums, etc. So basically, I want to engage more teachers and more students. I want to engage another subjects also. I think this is important for students because it improves literacy, ICT, citizenship, cooperation, collaboration, communication, and we can think in globally how to solve our problems. So don't forget to participate in the Globe at Night and also in our contest Dark Sky Rangers. So thank you, and don't forget we are losing our Sky Night, so maybe the dinosaurs are coming back and destroy all these street lights again.
Thank you. So we have time for a few quick questions. Yes.
Thank you. So, yeah, I think this project has good potential to be an international citizen science program in future, I mean, involving other people, other students in other countries. if you make a good platform for a citizen science project?
Well, I think so, but I have to improve some material, some resources. But I think so because I presented this scenario in Athens in marathons this summer, and I realized that is something like 265 visualizations in a few weeks, or 1 week or 2 weeks. So I think we can do it with schools here in Portugal, and we can do it with schools in other cities. And yes, I think it will be possible. Maybe we can manage something.
Just to comment on that, we are working with the team from Biodiversity to all, precisely thinking about, it's a Portuguese project, to do precisely this. So this will come next year.
Okay, we have time for one more question. I think your hand went up first. No, wait. That's okay, question.
Okay. Congratulations. It's
Thank
a
you.
really nice project. I personally would like to implement it in my school. So I'd like to ask how much time, how long did you prepare this, and how long did you take to really get to all these conclusions?
Well,
A year, 2 years?
No, it was in the last year.
Yeah.
And it take me something like 2 or 3 hours in the classroom to analyze the data, to make some calculations, because the students doesn't know how to do it in Excel file. And everything was made on the internet via contact with emails, with exchanging files on Google Drive. So we are always connected with the students if they have some questions about the work that they've done. But all the work I have to make at home because it's in the night. You have to make the observations at night, so it took me only maybe 1-2 classes.
Yep. Okay,
Yeah.
and you did that in your time in class.
Yeah,
Thank
and,
you.
how to explain the rules to the kids, and that's it.
We'll talk some more later. Thank you.
Yeah, you're welcome.
I want to say thank you very much. And if you have more questions, please save them for the coffee break.
So we move now, and Bonnie has to hand over the session to me. I have no idea what's the title of your talk.
The moon over us, moon over us.
The moon over us, of course. So it's my pleasure and privilege to present Bonnie, who is now going to have a hard time with me with timing, as she did with everyone. Bonnie is going to present The Moon Over Us, a project going on for several years now. And she's going to enlighten us about the beauty of this project. Bonnie, I'll let you know when you have 10 minutes and 5 minutes. Is that it?
Yes, thank you. Okay, so I'm now, the arrow keys, that's what I'm looking for. I'm Bonnie Thurber, and I am director of the iCollaboratory, which is a project that we started with all volunteers 5 years ago. 3 years ago. Oh, and this is where I live. We have warm, very hot summers and very cold winters. This one was particularly cold. These are some students from the USA. There's a class from a Chicago public school. There are 28,000 teachers in in Chicago, and also a class from McHenry. The school in McHenry is a rural school. This changes automatically. But I had 900 students in this project. So this is, I found this image, and I was watching paragliding in Nepal, and I thought, this is a wonderful image for the moon over us. So I gave credit to the person who presented it. So this is sort of my logo for the iCollaboratory. This was a project. It started out with Hongfeng Go from China asking me if we could do a project with China and the US. So I thought, okay. So I got US students and she got Chinese students, and we started the project. Then on the way, as I was going through this, I asked Gustavo Rojos, who is one of the people that I met at these conferences from Brazil, if he knew anyone who could help me. And lo and behold, he found Paulo Bretons, so who had some students who were working in schools. So some of those students worked with teachers to help us put things together for this project. Then I also, Katrina, and I were in the US, and then Herbert was someone who came to a GHOU meeting from Germany. He said, oh, we do a moon project. So I added his moon project. So we then had a sort of a handful of projects, and they all worked pretty well together. The projects not only included facts about the moon, but they also included feelings, things the kids really felt and thought about the moon. And some of the schools wrote poetry, drew drawings, a variety of things. And so I had them in this slideshow. So these are two statements about the project. One is from Stellan, who is an adult I know from Sweden. And then the other one is from one of the older Chinese students. So you get a little more information about the project from reading them. I'm not reading them, but you can. This is the places that we ended up working with were Nepal, China, the US, Brazil, and Austria. The project list for last year was, we talked about the full moon, then we talked about moon phases. We did a moon history, a history of peoples and their beliefs, and how the moon has affected them. Moon phases again, and then moon faces. Again, this is Hong Feng-o working with students in Beijing. This is a rural school in Illinois called Shiloh, from Shiloh, Illinois. There were 12 students in this class as opposed to the 30 students per class in the Chicago area, and I think probably 50 students per class in China. These are some things the Brazilians posted. Then this is a section of dialogue the students had. This is, Fred was a student from China. I don't know what his Chinese name was, but he said, call me Fred, so I did. Anyway, he drew some wonderful images. And as we go along, this folder was taken by his father. He told us some jokes. And the aha of this piece was, we all have the same moon. So then we sort of rolled into another, well, I've got pictures now, information from McHenry, from different students. And this is, they started working on moon phases as they were moving along, so that was fine. Alton was another smaller town in Illinois, which is very nice. And you can see that the A is for an adult. So Joyce F. was a teacher, and she was sort of, as they were creating these pages, she was sort of getting them to converse with her. And some of the questions she asked were very, very simple, but she got replies back. And that was the point, to get them to start talking. So this is the moon over Mokina, USA. I think the second dot there is just the reflection, the way the camera was set up. We also had the teacher from Shiloh told us that if we turned the flash off the cell phone and then took a very fast picture, they came out a lot clearer, which helped as we went along. Then the monthly cycle and influence on people. The students in Austria were writing papers with very serious data about are these beliefs, are traditions, things we think about, really scientific or not. And so they were doing all kinds of data researches and wrote papers about why you have your haircut on the full moon or the new moon, and does it have anything to do with actual beliefs, or what is the scientific fact? They went into births and deaths and people who are born during the full moon anyway, and wrote papers about the results. Then the students in the USA reviewed their papers and gave them some critiques. Then I was in Nepal doing a teacher workshop, and in Nepal, during this workshop, the German students came, or the Austrian students came online and started talking about their beliefs versus what the German students have found out. We had a very interesting discussion about science fact and philosophy coming from the heart. So it was really, for me, it was tremendous to have this discussion happening on Skype, in text, not in voice. Then this is just a sample of work from some of the kids in the USA. So we see an introduction, facts about the moon, and then a myth about the moon, and the myth about the moon is illustrated. Now we come to moon faces, and I had some beautiful pictures come out of this, some of the images. I also had Paulo telling me that I needed to have these things in the images, so I got a lot of images that were just the sky with the moon in it, and the point of that was we really can't tell where the ground is. The pictures could have been flipped or rotated. The object of this piece of the project was to find out if there was a difference between the way we see the moon in the northern hemisphere and the southern hemisphere. So, and then I had work from Nepal also, and the teacher in Nepal would have the kids write their work out, and then he would take it home and find a scanner, scan it, and email it to me. Then I would post it. So the rest of the information was actually posted by the children, but in this case, they did not have the ability to do that in school. So the teacher really wanted to participate, so we arranged for him to do this. I think it was a lot of work on his part. More about Nepal, from Nepal. So then here we have the moon over Nepal in March. Now, I have some pictures. This is the moon over Sao Carlos, Brazil, in May. I have some images that were actually taken on the same day, April 25th, that show the moon and Saturn, one from Brazil and the other one from Chile. But since they didn't have the land on the bottom, and you couldn't tell which way was north, I had some challenges of people saying, well, you know, they must have just flipped around it. Does the sky really work in reverse in the southern hemisphere? And I said, well, then, how does the moon look at the equator? And anyway, very interesting discussions. And so they started getting into the physics of why we get these views. I had one person who actually had solarium and looked it up to see what was happening. But this idea is a very good physics problem for children to figure out. So at the end of the year, the project was completed. What I'd done is I'd set up an opening survey and a culminating survey. We had these comments all the way through it. And at the end of the project, the kids were supposed to take the survey and then also write a reflection. So the end of the project, most of the kids thought surveys were fun, so they took them, but I missed a number of them also, and I didn't get a whole lot of reflections. one of the things that I've found is students have continued interest in sky gazing. So that was a very positive. This year I'm going to add badges and certificates because that kind of reward seems to be, I don't like doing that, but that kind of reward seems to be something that works with kids. And actually it works especially with Chinese kids, I think. Also the certificates, I've attaching, in the US we have CPDUs, and if you get enough CPDUs, it adds up to a college credit for the teacher. So the teachers will get certificates for completing the project with their students. In the US, a very good author wrote a book called Every Soul a Star. It's a fictional book, but it has a lot of science facts in it. And one teacher came in and said, even my boys who don't like to read this book, will read this book. And the book, actually, the second version that I got had a whole lot of science activities to do with observing the moon and the stars in the back of it. So that was a real plus for students and teachers in the US. However, it's not translated into any language. I was going to say parents were really enthusiastic about this because the kids came home and had to have the parents come out to look at the moon with them at night. In one case, the boy said, well, it was my mother. My mother had to come out and take the picture because in my neighborhood I can't go out at night alone. Now this year, we're repeating it. We'll be doing moon. The Chinese autumn moon has already passed, so we're going to be doing moon phases first. Then we'll be doing moon history, and then we'll be doing moon phases in the spring. And I think that may be better. This is about where to go to learn more. And this is just me and my team of volunteers that work on these projects. Thank you.
Thank you, Bonnie. Wonderful as always. I think we need Portuguese teachers volunteering to this work. We should have Portuguese teachers there. We don't. Embarrassing. Should have.
Oh, well.
We're starting this year. I bet we're going to have a flood of Portuguese teachers willing to participate. It's a wonderful project.
Okay, thank you.
Questions? We don't have much time. Okay, so let's thank all our afternoon speakers again. And
Could I just say, if anybody hasn't entered our little competition, we're going to do the draw right after the coffee break. So if you haven't yet, you still can.
so if you don't have this piece of paper that Sally has in her hand, come and get it, fill in and give your name to the desk down there. Don't go away. I have something to say. So, and it seems that Pedro also has something to say. First of all, those of you who appreciated Babacta Fresh's presentation, we have more during the weekend. There is a tour, as you know, to Alqueva. Make sure you talk to this gentleman over here. He will provide all the necessary information if you want to go there. And before you depart, and I know that not all of you are going to be here tomorrow or the day after, I would like to thank Pedro for supporting the organization of this meeting. But above all, I would like to thank all my team, Nucleus team, for putting up with me and all the hustle that was organizing this conference. I have the best team in the world. They are not here because they are all helping somewhere. Some of them are here. So I won't name them because there are many, many people running around the place to make sure that this is going smoothly. I couldn't have done without them. So thanks a lot to all the Nucleo team. I have a few members here who will make sure to inform each and every one of you. You are the best. Thank you.
Thank you, Rose, and I think I speak on behalf of everyone that this was, you have done an amazing job. Organizing 2 conferences with so many diverse people coming from all around the world must be very, very hard, and a privilege as well, I think, and it's going very well, I think, both conferences, so congratulations to everyone. Very short announcement. We have some educational material about radio astronomy for primary schools. I have enough copies for everyone. It's called The Invisible Universe, that was produced by me and my team. I have a box on the back of the room, so just feel free to take 1 or 2, maybe 1. And it's quite heavy. And please use these resources, and if you have some comments on feedback, I will appreciate that you send them to me. Thank you.
Coffee break, 15 minutes, if you don't mind, okay?
Over there. It's better. Because we have. No, you cannot take it. Photography over there.
Copyrighted.
It's more expensive. Okay, I pay. Say crab nebula. Crab.
Crab.
No, you cannot take a picture because the memory is full. Oh, you do. You
can delete
You
one.
have to delete. I delete your pictures. Oh, it's over there. You are. Take a look. Yeah.
Come up.
Oh.
Well, it's probably to see just here. If not, it's going to be like, yeah.
No problem. Oh no. Mistake.
But I set it up and then.
Okay. 68.
I want to get some cash, but the bank closed at 3.
Really? Bad luck. Yes, because
I mean, I need to do some exchange.
The exchange. No, okay. So you
they're
have-
closing early here in Portugal.
I
Yeah.
have money if you need it, and then you can pay me back.
Next year.
Come on. I
Then
will
pay-
call the
I-
IEU directly and
I
ask
pay her
for-
a trip then.
Yes, you should.
Then you
Let
earn
me see. Something like
Okay.
more. So you need Google Fusion tables.
Okay.
Associate with Google Drive. Okay. So you can, for example, let's try, I don't know, something like maps.google.com. Oh. I'm gonna choose randomly here a city. Let's try. For example, this area.
Okay.
Some kid makes some observation here. A couple of kids in this street and in another street. So he can take geolocalization. Localization. For example, this. Let's take another. Maybe in this street. And another one. Only 3. This is a river. Maybe here. I think it's the center of a city. So 48 something. Control C. Control V. Well, let's suppose power 125, 200, 100, for example. Number stars. Let's put here 20.
So
10.
the number of stars that they can see, right?
Yes, but using like a little bit card with a hole in the middle and just going point to, for example,
Okay.
to Orion and counting the stars in Orion.
So you decide an area that everybody has to look to.
No, they have to look in the streets in the where where they
area
live.
of the sky.
Yeah, the area
Ah,
of the
you
sky.
can, just
I-
the area, yeah, the area
I'm
on the
talking about
sky,
the area
yeah.
of the sky.
Yeah.
Yeah, in every street.
Let's
around,
suppose
yeah,
that's
yeah,
it. I give you, a short example. So you can choose here new. Now, Google Fusion table. Really? Why? Uh, okay. Yeah, save password. Don't get it. Ah. So you can create an no into table. Why? So stupid. Sometimes Google spreadsheets, so you can pick up your Google spreadsheet. I don't need to be open anymore. Okay, accept. You can acquire all the data and ask the students to fulfill a Google form, you know? Yeah. You will have the data in a Google spreadsheet, so you can import the Google spreadsheet. You see it? You can import to here to Google Fusion tables. Then going to read the data and try to identify the geolocalization data. This is the most important to make the maps. It's not mandatory, but if you want to make the map, you have. It is necessary to be in there the geolocalization. So on. Okay. So here's the fusion table. So you can create.
And they automatically know.
Yeah,
it.
automatically. Here's the points, the dots.
Yeah.
So if you want, you can create a heat map. Okay.
I get it.
So if you increase the number here, the heat map will be much higher.
Okay.
Sorry, so no, I didn't get it. Come back again. So this is the
Heat
radius.
map of numbers of stars. You can see that here you can saw less stars than in these two spots.
Ah, okay, because you count the number. Okay,
It's
but
according
the
with the
radius
number.
you establish.
No, the radius you can establish.
Ah, okay. So you establish the
Yeah, you can establish, but you are not going to use a big radius. Of course, this is not they don't make any sense.
just to make it visible.
So just to make it visible, something like that. So when you can pull out, you can see it, and it's almost an approximation that we have in this all these streets. So it's a good extrapolation, not so bad.
Okay.
But if you want only to show by a spot, you can do it also. You can change here, for example, 2 buckets, and you can choose, for example, 3 buckets, and you can express in different colors.
So
they
you
can-
have a scale.
So you have a scale.
Okay.
So if you want to be correct, this is because I have it also in spots. I don't know if you saw it in the image. I have to go to my presentation to see the
Well, I remember the map anyway. You remember that map you are going to show us, or?
yeah, there was different colors. The red one was the most expensive street. So you see less stars. So it's the most pollutant with light pollution.
But and the cost on everything, you just count the lamp you